100 subscribers. It's not much, but it was a big milestone for me. Thank you for your support and keep supporting, and I will do my best to deliver more great tutorials like this. So many of you ask me how to detect objects other than faces, like mobile, like chair. One of you even asked me how to detect. He wants to detect his cat. So how can he do that? Mm, the best answer will be like to use a hard cascade classifier, but the problem with that is training the classifier is very difficult and takes very much time, and we don't have not much lot of these classifier around the internet. So after a little bit research I came up with the solution. So I have this image of this Raspberry Pi box, cover box, and I want to detect this object in my video. So I already cropped this image and I have stored it somewhere in my drive, and this program will try to find this object in the video. So let's see how it looks like. So here am I, and this is the Raspberry object. So it is using something called Swift feature extractor and one feature matcher. So it's extracting the feature from this image and it is matching where it is in the video frame, and it's drawing a polygon over it. So I think it's not as good as Cascade Classifier, but it's the best I came up with most easiest way possible. So let's see how we can do this. So let's go to your project folder and create a new folder. Let's name it object detector. And let's create a new file, Python IDLE file. And save it in that folder, which is in my case tutorials object detector, and let's name it object detection, or let's name it Swift object detector. Okay, so let's start our program. Let's start the coding. So like in each and every OpenCV script, we need to import the CV library and the NumPy library, and before going forward, let me explain this a little bit. Okay, so what we have to do here, we have to get a sample image which is called training image. Image in a predefined folder. Second is we have to create a feature extractor. We need to create a feature extractor. Create feature extractor. And third, we need to create a feature matcher. Feature matcher. And lastly, we just have to draw a rectangle on the detected object. Draw the boundary. Okay, so first thing we need an image in a predefined folder. So let's create a folder here. We are going to call this training images, training data, and here I am going to place the image. So I already have the image, means I already have some sample images. You can create your sample images. Just make sure that image only contains the object you want to recognize. So crop everything other than the object. Okay, so I'm going to use this one. Let's use this one. Okay, let's use this one. And paste this image and name it training image. Or train image, let's say. Okay, let's go back, and now we have this one. Check. Now we have to create a feature extractor. So let's create a feature extractor. The feature extractor we are going to use is called SIFT, which stands for here scale invariant feature transform. And this tutorial is also compatible with SURF, which is stands for speeded up robust feature. So you can either use SIFT or you can use SURF. The difference is SIFT takes a little bit more time to calculate the features, but these are more accurate features, and SURF is more faster but less accurate. So in my case, you can use either of them. So let's create a feature extractor. I'm going to call it detector equals cv2 dot sift, and if you want to use surf, you just replace this part with surf, and that's it. That's the difference here in the code. Oops. Okay, so we have created the feature extractor. Yeah, it's that simple. Now we have to extract the feature using the feature extractor. Let's make it check first and feed it to the feature matcher. So let's first create the feature matcher. Here the feature matcher is where that we are going to use is called FLANN based feature matcher. So let's create that. FLANN BACD matcher. It takes some parameters which we are going to define before initializing it. Let's define them. FLA and sorry params equals, it's a dictionary actually, dict, and here there are two types of parameters here. Algorithm that this extractor feature matcher we're going to use. We are going to use FLN index KD tree, RITHM. Algorithm equals, it is called FLANN index underscore KD tree, and the tree value equals 5. This is the parameter. But the thing is, in OpenCV library, this flag is not initialized, or this flag is not inbuilt. So we have to define this flag, which is actually 0. So we can actually write 0 there, that is also fine, but it's better to uh, know which flag we are using, and you can check the value of the flag from the OpenCV document. Okay, so we are done with the initialization. Now we have to feed this parameter in the constructor, and we have to give a empty dictionary there. It's actually a OpenCV bug. So it's fine. We are ready with the feature matcher. Now let's get the training image loaded in the program. So for that we are going to use the OpenCV imread train image equals cv2.imread, and here we are going to provide the path, which is in this case this folder slash the file name training data slash the file name. The file name here is, let me copy this, paste it. Okay, so but we need this file to be in grayscale, means this is a color image. We want it to be black and white, or in more general it is called grayscale. So if we give 0 there, it will become a grayscale image, means it has it doesn't have any multiple channels. So now we loaded the image. Let's calculate the features or extract the features from this image beforehand, so that we don't have to calculate it every time in the frame. So let's train key point. Okay, let me tell you first that this detector will return a variable called key point and descriptor. So key points are basically the coordinates where it find the feature, and descriptor is the description of that key point. Let's say this is a key point where let's say, okay, let's say this corner is one key point, and how big or small this feature is, that will be, or what is the direction or orientation, all this information will be stored in the descriptor. So one is the coordinate and one is the descriptor. So for the training image, I want this variable to be named as train key point comma train descriptor equals detector dot. Now this will detect and compute the description, so it is called detect and compute. the input image is this one. Let's give it there. And the mask, the second parameter is the mask, which is we are not giving any mask there, so give it none. So only one parameter is enough.